So we're back in the DMM test room again today because we've been asked a lot of questions, especially online, about the strengths of knotted DYNEEMA. So we thought we'd start by doing what we call the static test, which is actually a very slow rate of pulling the slings. And then we'll go out onto the drop tower afterwards and do the dynamic tests, which are a lot more akin to what you would set up in a climbing situation. We're going to use 11mm DYNEEMA, 8mm DYNEEMA, and then various types of knots. A tape knot or a water knot, a figure of 8 knot, a double fisherman and a triple fisherman. And we've also frozen some overnight and we've soaked some overnight, so it'll be interesting to see how the moisture and the temperature affects the strength of the sling. So we've done all the tests in the laboratory, which were what we call the static tests, where the load's applied through the slings at a very slow rate. We're outside on a drop tower now to try and assimilate more climbing situations where you put dynamics through the system. And this will actually force the DYNEEMA knot to absorb the impact over a much shorter period of time, and it'll be interesting to see what happens. What we've set up here is an 80 kilogram mass and a fall factor 1 on a triple fisherman's 11mm DYNEEMA. We'll also do a fall factor 2, and this is to simulate what would happen if you climbed above your belay whilst clipped to a DYNEEMA sling, knotted in this way, and they were to slip off. So as you can see, the knot held up no problems with the fall, although there has been about 5 centimetres of slippage on each of the tails in the sort of take-up as it's absorbed the impact. We're going to do the same test now with a fall factor 2 situation, and we'll put a fresh sling in there with a fresh knot and see what happens. So that was fall factor 2, 60 centimetre sling, 80 kilogram mass, and the knot has gone catastrophically just at the entrance there. The peak force on that was between 14 and 15 kilonewtons, and yeah, kind of what we expected from a DYNEEMA knot. What we're going to do now is 8mm DYNEEMA, and it's same 80 kilogram mass. We've tied this to about the same length as a dragon cam, fully extended. We're going to do fall factor 1 and fall factor 2 and see what happens. Okay, well that's all the testing done. We've been outside doing the dynamic testing and inside doing what we call the static test, and that's 1.5 millimeters per second that you actually pull the sling apart at, so virtually static. One of the surprising things was just how much temperature affected the strength of the knot, not just on the static test in terms of making the frozen ones being the strongest of all the slings, but actually in the dynamic tests, the heat generated within the knot is actually enough to break it at a lower load than on the static test. So yeah, we've broke lots of DYNEEMA, and the main thing is that knotted DYNEEMA, despite looking quite strong in the static test and on paper, when you introduce the dynamics to it, can be very weak. These are proper at a belay situations where you might step up from your sling or from your cam, and as you place another piece of gear, you might slip off and load it in a certain way, and the knotted DYNEEMA just couldn't handle some of the dynamics involved. The heat build-up within the knot is enough to make them fail catastrophically at a much, much lower strength. If you add that to the fact that knotted DYNEEMA actually can work itself loose while you're just using it just from carrying it, getting it in and out of your rucksack, due to its slippery nature, then knotted DYNEEMA is not ideal for using in climbing situations. To give you a comparison, we did drop a fall factor 2 60cm stitched sling, and the peak impact force was at 25 kilonewtons and the sling remained intact.